So here's what all data says about the 99 Grand Cherokee. And so this is the California emissions, and this is federal. We have federal. So we have an O2 sensor right here on the passenger side, and then we have an O2 sensor after the cat that you can see very well from the driver's side, and Jack is going to show you that under the car.
So as Keely said, we have federal emissions. So we do have our first O2 sensor is before the cat. It is right there. And then we have our catalytic converter is just downstream from that. And then right behind the catalytic converter, we have our second O2 sensor on top of the exhaust right there.
So at ambient temperature, we have 68 degrees before and 68 degrees after, and that is the temperature of the room. So we're gonna go ahead and start with the propane. So we're gonna take the initial readings, like 142 and 218 or so, somewhere around there. And then we're gonna feed propane into it and see the temperature change.
So we have here some tests from the cat temperature. First we have the cat temp at idle. Second we have cat temp at 2000 RPM. And then we did cat temp with a rich condition, which we added propane, and cat temp with a lean condition, which we pulled some vacuum lines. So for our cat temp at idle, you can see that as the car was warming up, it had a temp at about 221 before the cat and about 107 after the cat. And you can see that it gradually increases as the car reached operating temperature, and roughly the same with the post-cat reading. Then at 2000 RPM, you can see roughly the same increments of the cat temperature increasing as time went on. And then with propane, since the car was running extremely rich, the cat was heating up as it was burning off the extra hydrocarbons inside of the cat itself. So you can see that the pre-cat temp stayed roughly the same, but as the cat heated up to burn off all of the extra hydrocarbons, the temperature after the catalyst converter was increasing as time went on. And then with the lean condition, we can see that the temperature did increase over time, but the longer it ran, the closer the post-cat temperature got to the pre-cat temperature.
So here's the upstream sensor for the Jeep, and it's switching pretty well between lean and rich. So now we're going to see how the downstream sensor acts to the switching and how the cat is doing. So our downstream O2 sensor is not changing voltage very rapidly, so that is a good indicator that our cat seems to be working pretty well at the moment.
So we currently have the scan tool hooked up to the car, and we're looking at our upstream and downstream O2 sensors. We're looking for the cross count for the upstream, which this graph is roughly a minute long. And if we look at our cross count here, we can see that it is 21 times that this crossed from lean to rich in roughly a minute. And our downstream sensor stayed pretty consistent up until that spike at the end there, which if we scroll down here, we can see that that roughly matches our short term for our upstream sensor, and then that spike is from the long-term adaptive spiking up there at the end of our graph.
So scan tool wise, we have a catalyst monitor, but it has not been completed, probably because it hasn't been through the right drive cycles, but we can't do that, so we're just looking at the scan tool to see what's there and what's not there.
So this is the procedure that we found for getting the catalyst monitor to run. To start off with, your mill light must be off, there must be no DTCs. Your fuel level should be between about 15 and 85%. Your engine should be warm, and the engine should have been running for about a minute and a half. And when you do the procedure, your engine should be running between about 1350 and 1900 RPM while you are driving. When you are driving, you should idle the vehicle first, just to make sure that the vehicle is at operating temperature. And as you're driving down the road, you should make sure that you're driving between about 30 and 45 mile an hour around 2 minutes.